Planck's equation. Now I've mentioned Planck's equation before, where E represents energy. Later on, we'll look at what this energy really means. For now, we're just looking at the calculation. And in order to calculate E, which is energy, we use a constant H, which is called Planck's constant, multiplied by the frequency of the electromagnetic radiation. Now, Planck's constant has a specific value, which should be given to you, and its unit is joules by seconds. And given that Planck's constant must be supplied to you, and you are calculating E, which is energy, multiplied by frequency, and we've looked at a previous equation with speed of light and wavelength, what this means is where you see frequency, it can be replaced by c over lambda, which is the speed of light over lambda. Right, and you're going to see that in the equation on the right, E is equal to hc over lambda. And what we're going to see next to that is hc with a symbol which is used to represent wave number. Now, wave number is the inverse of wavelength. I want to talk about it a little bit. Right, so where we have wavelength, which is the distance between two waves or two crests of two waves, we can take lambda, which is wavelength, and if we express wavelength as its inverse, 1 over lambda, this new number which is obtained is what we call wave number. Now you may see wave number in the past papers, right? Not to get confused, just be aware that 1 over wavelength is equal to wave number. Right, we will do questions later on. Usually you are supplied with exactly what you need to calculate E. You're given Planck's constant, frequency, or wavelength with the correct units. But we go through it in detail just in case. So once again, you're given Planck's equation. E is equal to Planck's constant by frequency. If you are supplied with frequency, that means you can calculate the energy value, which is E. We're going to go on to look at some calculations, but just for now, what you are listening to here is what H represents, what wave number represents, and that wavelength and wave number are indirectly or inversely proportional. So where wavelength was measured in, let's say, centimeters, wave number will be in cm to the minus 1. Or if wavelength was in nanometers, wave number would be nm to the minus 1.